Hello everyone, now we'll see the interfacing of a motors with the Arduino Due. So here we can see the Arduino board that we'll be using here. So here we're going to explain the interfacing of motors with the Arduino Due. That here we have to interface, that is a DC motor as you can see here, and here we have a stepper motor, and here we have a servo motor. So we are just going to interface each and every motors individually with the Arduino Due and just check how do they work. And to interface these boards, that is these motors, we need certain components that needs to drive the motors. So I'll be explaining to you each and every motors and the corresponding components that is required to drive the motors. So before that, I just give an introduction to an Arduino Due. So Arduino Due is a microcontroller based 54 digital input output pins, of which 12 can be used as pulse width modulation output, that is PWM outputs, 12 analog inputs which run at amazing 84 megahertz clock signal. Now we see that there is a DC motor here. So here you can see a DC motor. A DC motor relies on the fact that like magnetic poles repels and unlike magnetic poles attract each other. So that is how a magnetic works. So if you connect a DC motor directly with this Arduino Due, so there is a chances that it might damage the board, because the Arduino board supplies just 130 milliamps and the property of magnetic coil in the DC current draws more current. So the DC current requires more current than that is supplied by this Arduino Due. So for this reason, here we have an IC that is called L293D driver IC, which we make to run the motor in both direction with the help of this driver IC. So this makes to enhance the power supply that is required to drive this DC motor. And next we have the stepper motor. So this also will be interfacing with this Arduino Due. So the stepper motor is a brushless DC motor electrical motor that divides a full rotation into a number of equal steps. For every pulse it moves the shaft to 1.8 degrees. So again, there is a similar issue that we saw, that is we faced with the DC motor. So if you connect the stepper motor directly with the Arduino Due, again there is a shortage of power supply that is required to drive this stepper motor, because this Arduino Due board supplies just 130 milliamps on all digital IO pins, while the stepper motor ratings is more than 300 milliamps. So for that case, in order to overcome this drawback, we will be using an IC that is ULN2803 IC, which provides a current rating of 500 milliamps, which saves our board from being damaged. So this enhances the power required for the stepper motor, which this Arduino Due is not able to provide individually. And the next we have the servo motor. So as now we'll see, a servo motor are geared DC motors with the closed loop circuitry incorporated within them. The basic configuration of a servo motor composed of a DC motor. It consists of a gearbox, a potentiometer and a control circuit. As we know, servos are controlled by sending an electrical pulse of variable width or pulse width modulation through the control wire. There is a minimum pulse, a maximum pulse and a repetition rate. A servo motor can usually only turn 90 degrees in either direction for a total of 180 degree movement. Now we'll see a simple demonstration of how we can interface each and every motors that I explained to you with the Arduino Due, and we'll see how it works.